So today let's talk about the quadratic formula. And what I want to start with actually is talking about where the quadratic formula comes from. How do you get that? Well, the way you get it is it starts with the old traditional standard form of a quadratic, which is ax squared plus bx plus c. And if we just set that equal to 0 here for a moment, and if I were to solve that for x, I will come up with the quadratic formula. So how do I do that? Well, let's see, you know that in order to, we're going to solve this actually by completing the square, so we need to get rid of this value right here, or not get rid of it, but move it to the other side. If I do that. And then you also know that you can't have this value right here. You can't have a lead coefficient. So let's divide everything up by a. Now this is going to get a little messy, but I'm confident that we can do it. Okay, so now to complete the square, remember you got to take this middle term right here, and we have to divide it by 2 and square it. So if I take b over a and divide it by 2, I get b over 2a. If I square it, I get b squared over 4a squared. If you don't believe me, go ahead and do b over 2a and square it. Okay, but that I promise that's what it comes out to be. So the next step is to factor, and I believe in one of my other videos I told you that in order to factor a perfect square trinomial, what always happens is where you're going to use the square root of this right here. So the square root of that is b over 2a times x plus b over 2a. Over here, if you get common denominators, you're going to end up with, I believe it's going to be 4ac over 4a squared plus b squared over 4ac. Okay, so things seem like they're getting a little messy, but let's see if we can clean some stuff up here. Let's see, over here on the left, I can rewrite this as x plus b over 2a squared. Over here I get b squared minus 4ac all over 4a squared. And hopefully you can kind of see right here that that should look familiar right there. Okay. Okay, not really sure what just happened right there, but sorry about that. So let's go through and square root. Okay, so you get x plus b over 2a equals plus or minus the square root of b squared minus 4ac all over. Down here you get 2a. Okay, almost done. Let's see if we can kind of move up here. Sorry, it's getting a little squished. If I move this b over 2a to the other side, I then am going to get x equaling negative b over 2a plus or minus square root of b squared minus 4ac all over 2a. And if I put it all together, you end up getting negative b plus or minus square root b squared minus 4ac all over 2a. So I apologize that it was all squeezed together right there, but that's where the quadratic formula comes from. I'm sure that's something that you're not going to really do on in your spare time, but I think it's important for you to know where it does come from. Now, there's an important part of the quadratic formula, and that's called the discriminant. The discriminant, if we're looking at the quadratic formula, let me just rewrite it one more time. The discriminant is this part right here on the inside of the square root. And so what the discriminant tells you is how many and what type of solutions you're going to get. If I go through and if I solve any sort of quadratic using the quadratic formula, if b squared minus 4ac, if that middle part, okay, ends up being greater than 0, then I know I'm going to get two real solutions. Okay, so in other words, if that part in here is a positive number, I'm going to get some real numbers. So I'm going to get some actual values that are x-intercepts. However, if that b squared minus 4ac is equal to 0, so in other words, all this stuff kind of cancels out, then what that's going to tell you is you're going to get only one real solution. Okay, and the reason for that is if this is all 0, then you're not going to be needing this plus or minus part. It'll just be negative b over 2a, and so it'll just be one value. And then finally, if that b squared minus 4ac is less than 0, so in other words, if this value up here is a negative, that means you're going to get a complex number. Okay, and so you're going to get 0 real solutions. Okay, you'll end up, as I said, you'll be getting complex values. Okay, so let's talk about how do we solve. So let's do kind of an easy one right here to begin with. And so when I solve using the quadratic formula, it's pretty straightforward. You know, you just simply need to know what your a, b, and c value is. In this case, my a value is 1, my b value is negative 9, my c value is 14. So if I did quadratic formula with this one, it would be x equals negative b plus or minus square root b squared minus 4ac all over 2a. So let's clean that up a little bit. So I get 9 plus or minus square root of 81 minus, looks like 56 all over 2. Clean it up a little bit more. 9 plus or minus the square root of 81 minus 56, I believe, is 25. Okay. So we know what square root of 25 is. 9 plus or minus 5 over 2. So if we just kind of bring this over here. So my two results are going to end up being x is going to equal 9 plus 5 divided by 2 is 7. And 9 minus 5 divided by 2 is 2. So there you go. There are my two results, 7 and 2. Now I realize that this is probably a quadratic you could solve by factoring, but again, I wanted to do it just so you can see that you can solve any quadratic using quadratic formula. And also, if you notice that, see how the b squared minus 4ac, the discriminant here was a positive number, and what did we do? We got two real solutions. Okay, so let's try another one. What about this one right here? Well, the first thing again is to identify, whether you write it down or just mentally identify what your A, B, and C is. I would label my A as 7, B is 0 because there's no x term here, and C in this case is 2. So if I do quadratic formula, I would do x equals negative b plus or minus square root b squared minus 4ac all over 2a. So I get plus or minus the square root, and it looks like it's going to end up being, what, negative 56 in there over 14. And so you notice your discriminant is negative here, so that means we're going to get complex values here. And so let's simplify this a little bit. Square root of negative 56 plus or minus, let's see, I believe it's going to end up being 4 root or 2 root 2I root 14 all over 14, which we can simplify a little bit to be plus or minus I root 14 over 7. And there you go. Nothing too terribly difficult right there. It's actually kind of nice when you have one of your values being 0 because it simplifies some of the work. Okay, so let's try one more. How about this one right here? Okay, this one's a little more complicated, or looks like it's got some bigger values. Let's see what happens here. So let's just jump right into it. So if I were starting, I would write x equals negative b plus or minus b squared minus 4ac all over 2a. So if I was going to do this one, then some things I could simplify would be, I could obviously simplify the 24 plus or minus square root. Negative 24 squared is going to be 576. And now it's minus 4 times 9 times 16. So minus 576. Well, that's convenient. So what looked like it was going to be a terrible problem, or a kind of a big number type problem, that all goes away. And we're just left with 24 over 18, which can be reduced, obviously. You can reduce it by 6, I believe, so you end up with 4/3. And again, going back to our discriminant talk, you notice that the discriminant here was going to end up being 0. And so what that does is it takes the plus or minus part out of it, meaning that you only get one result. And for those of us who are like to kind of think or see these as visuals, if this said y equals all this stuff, you would end up getting you a parabola, that looks something like this, where it would come down, touch, come down, and it's supposed to be touching right there. It'd come down and touch the x-axis at one spot at 4/3. There wouldn't be two x-intercepts, versus a problem like this one up here, number 1. This would be an example where, because there's 2 here, you'd have a graph that would look, this is just a rough estimate, but it would look something like this, where here's 2 and here's 7. And then this one over here would be an example where if you had a parabola, it would not cross the x-axis at all. So those are the 3 different types of parabolas in general that you could have. You could have different ones that go upside down, but for the most part, you're going to have a parabola that either has 2 x-intercepts, 0 x-intercepts, or 1 x-intercept. So I hope that makes sense, and hopefully that helps out. Sorry about that.